All right, hello again, pre-calculus people. So we're going to continue talking today about exponential log functions, in particular the definition of an exponential log function, kind of how they relate to each other algebraically. So in the last couple of videos, we talked about graphing the two functions, and you see the two graphs here. You see the exponential function and the log function, and notice we talked about them being inverses of each other. And all that means, and this isn't something that's going to be tested per se, but the graphs of the parent functions are symmetric about the line y equals x, which is that dotted line going through here. But really what we're going to be doing, the reason we need to talk about the definition and the algebraic side of things as opposed to the graphical side is so that we can solve equations, right? And because just like back in the day, like back in your algebra classes, if you had a squared function, then we could do that with a square root. Or if you just had, if you had like 3x equals something, you divide by 3. Always doing that inverse operation. So there's not a whole lot of really to talk about. I'm not too worried about this. So this line right here, I like kind of highlighting. These are just all true statements. Again, you don't need to memorize these by any stretch. But notice they all kind of combine an exponential and a log in different ways, ends up being just plain old x. In other words, the log and the exponential basically kind of cancel each other out, okay? But here is the big part of what I want to talk about today, and it's highlighted right in the middle of the screen. It's the definition. You have to know this. So the way we would read this out is log base b of a equals x, if and only if b to the x equals a. Okay, so a little bit of vocabulary here for you. We do call b the base, and notice on both sides of the definition, we have 3 letters. There's b and an a and an x, right? So the b is the base because it's the base of the exponential. So it's the base. We call a the argument. And then x is the exponent. So if you take just 1 second, if you want to pause the video for just a second and kind of look at both sides of that definition, because what this is going to enable us to do today is if we have a logarithmic expression, we can write it as an exponential, or vice versa. If we start with an exponential, we can write it as a log, okay? Now, just a couple side notes that deal with logarithms. There's most of the time you're going to see a base written as that little subscript. Sometimes, though, you won't. Sometimes there's 2 situations where you won't see the subscript written. The first one is called a common log. This is from kind of back in the day. If the base is 10, you generally don't write it. So like log base out of x would just be written as plain old log x and not write the base. So if you don't see a base, it's automatically 10. And then the second case is for what's called a natural log. And that's where the base is actually the number e, which is called Euler's number. This is actually called the natural base. And we'll get more into that in a few days if we start doing some science and financial applications. But the upshot of this is you will never, ever, ever see log base e of x. This is always written as natural log, which is ln. Okay, so if you see just a plain old log x, that means the base is 10. If you see ln x, that means the base is e. Any other base, you'll see it as a subscript or as the base. Okay. So all we want to do is kind of go back and forth, right? So using the definition, and I rewrote it over here, highlighted again, just so you can kind of see that for this section. So on these 4 examples, A through D, I start with a log, and I want to write it as an exponential. Okay? So on part A, again, if you want to label these things, so we know that's the base, that's the argument, and that's the exponent. So my exponential would just be 3 to the 4th equals 81. Done. That's all she wrote. Okay. By the way, these are all true statements. So there's nothing to solve. We're just rewriting it. That's all we want to do. Okay. Part B, again, base, argument, exponent. So this would be 9 to the 1/2 equals 3. Now, I would totally count this right, but if you want to be fancy about it, if you remember, a 1/2 power means square root. So really what this is saying is square root of 9 equals 3. Anytime you see a 1/2 power, that means a square root. How about letter C? Log of, there should actually be another 0 in here. That's kind of a typo, so it should be 10. It should be 100,000, not 10,000. So log of 100,000 equals 5. And again, remember what I said a second ago, there's no base there, so that means the base is 10. So this would be 10 to the 5th equals 100,000. And then the last one, that's our ln. Remember, this is an L. Pet peeve of mine, people writing one N. So the ln of that, and again, that means anytime you see ln, the base is automatically e. So it's e to the 3rd is about equal to that number. Okay, so that's going one direction, log expression to an exponential, and then the other 4 is going the other direction. So if you want to pause the video and see if you can write these without me even doing the examples, and I'll zip through those real quick and we'll finish this one up. So again, so we have our base, this is our exponent, and this is our argument. So we transfer that into a logarithm. We have log base 2, and remember that subscript is kind of below the line, as it were, of 32 equals 5. For the square root of 64, remember we did that on one of them up above there. So 64 to the 1/2 power is the same thing as saying square root of 64. So it's really saying 64 to the 1/2 is equal to 8. So that means log base 64 of 8 equals 1/2 as a log expression. For letter G, again, our base is 10, so I don't even need to write the base. I can just write plain old log of 1 million. Just one more 0. Sorry about that. Try that again. Equals 6. If you put a 10 down here, again, I'm not going to count it wrong because it's not, but you will usually not see a 10 written there. And then the last one, e to the 2.5, you'll definitely never see this written as a base. Again, if you see e, it's automatically ln. So you can do ln of 12.1825 is 3. And that's it. That is the whole deal with writing exponentials as logarithms or logarithms as exponentials using the definition of a logarithm. As always, if you have questions, let me know. Send me an email, come into tutoring. Until next time, stay safe.